Section 5.5 is the last section that we're covering this semester. It's on something called U-substitution, which is an integration technique. And it's really just undoing the chain rule. So I've written up the chain rule here so we can remember what that looks like. The chain rule is for taking a derivative of a function composition. So if I'm taking the derivative of f of g of x, then what I'm going to get is a product of my two derivatives, f prime and g prime. But f prime will be evaluated where I was evaluating f, which is at g of x, and g prime will be evaluated where I was evaluating g, which is just at x. Okay. All right. Now, we've learned that integration and differentiation are essentially inverse processes. So if I have a derivative formula, there's going to be a corresponding integration formula. So if I were to integrate this derivative, f prime at g of x times g prime of x dx, that would equal, my antiderivative would just be this function composition. And of course, if this is an indefinite integral, we're getting a family of functions, so there will be that plus c. Okay. Now, I want to just point out three things that I notice about this integrand here, which is just the derivative that I get when I use the chain rule. Okay. One, I have a product of two functions, because I have just f prime multiplied by g prime. Two, one of the factors is a composition. This factor right here, that's g of x plugged into the function f prime. So one factor is a composition. Okay. And then the third thing I have is that the two factors aren't totally unrelated to each other. It's not like I just choose two random functions and multiply them together. We'll learn how to do that in 3b. Okay? But the second factor, this one here, is the derivative of the inside part. So the other factor is equal to the derivative of the inside part. Okay, so these three things are going to be my clues that I might need to be undoing the chain rule. Now, this section is a method called U-substitution. That's basically going to be a notational trick to make this process of undoing the chain rule a little bit simpler. What I want to do is just work through an example, just knowing the chain rule and trying to sort of unravel it, and then we'll take a look at this notational trick of doing what we call a U-substitution that just makes the process a little bit easier. Okay, so let's try taking the integral of cosine of x times the square root of sine x dx. Okay, so notice in this case I have all three of these things. I have a product of two functions. I've got cosine x being multiplied by the square root of sine x. One of these factors is a composition. That's going to be this one right here. This is sine of x plugged into the square root function. So the inside part is sine of x here. And then the other factor, cosine x, well, yep, that's the derivative of that inside part. My inside part is sine x, its derivative is cosine of x. So it looks like this actually matches this formula right here. What I need to do is figure out what's f, what's g, all of that good stuff. Okay. So let's see. Looks like g of x was supposed to be the inside part. So I said g of x here was equal to sine of x, and then g prime of x was equal to cosine of x. Okay, so I definitely have that. Now, f prime is the function that I'm plugging g of x into. So it looks like f prime of x is the square root function. That's the function that I'm plugging sine into. Notice f prime is not the square root of sine of x. That would be f prime evaluated at sine of x. f prime is just that square root function, which I could write as x to the 1/2. So I've sort of figured out what f prime and g prime all are to make this match. So now I know that my antiderivative is going to be f of g of x plus c. Well, notice I already know what the g of x is because that shows up on both sides of the equation. Okay, I need to figure out what f is. So the integration or the anti-differentiation that I need to do is really just focusing on that square root function. I see a whole bunch of trig going on here, but I'm not going to be finding antiderivatives of trig functions. I'm going to be finding an antiderivative of the square root function. So I can say, well, f of x, that would have to be an antiderivative of x to the 1/2. I know how that works. That's going to just be the power rule. So that's going to be x to the 3/2 divide by that power, so that's going to be multiplying by 2/3 plus c. Okay. All right, so now I've got f and g. That's enough to figure out what I've got on the right-hand side. So this should be f of g of x plus c. F was this function right here, 2/3. We're going to take our input and raise it to the 3/2, and then of course add c. Our input is supposed to be g of x, which is sine of x. So what we get here is 2/3 sine x to the 3/2 plus c. Now if I want to check that that works, anytime I take an antiderivative and I want to see if I did it right, I can take the derivative, and it should take me back to my original integrand. So let's see, if I did take the derivative, I'd use power rule here. So I'd bring the 3/2 down, it would cancel with the 2/3. So I just get one copy of sine x to the 1 less power. That would be sine of x to the 1/2 times the derivative of the inside part would give me my cosine x. So it did work. Okay. Notationally, it took a little while to write down all of the pieces and see how it fit together, but we were able to work that out. What we're going to do in the next video is revisit this exact same problem, but I'm going to show you the notational trick that we call a U substitution that just makes the bookkeeping involved a little bit simpler.